Hello everyone, this is Devbyte. Welcome back to episode 2 of our Unity FPS controller series. In the previous video, we created our basic movement system, mouse look, and gravity. In this episode, we're adding 3 essential FPS mechanics: jumping, sprinting, and crouching. Without wasting any time, let's get started. And since we already created the ground check system, adding jumping becomes super easy. Let's open up our movement script. Let's start coding our jumping mechanics. We already created a ground check system. So now for jump, we need a jump force that controls how high our player can jump. Let's create a float for our jump force, private float jump force, and initially set this value to 1.5. Next, we need a bool to store our input from button. Private bool is jumping. As we already have a method that handles our input, we'll use this method for our jumping input as well. Inside this method, we'll say our isJumping bool is equal to input dot get button down of string jump. We use get button down because we only want the jump to trigger once when the space key is pressed. Now let's create a new method to handle jump. Here we'll say private void handle jumping. Inside this, we'll first check if our isJumping equals true and also is grounded. Then we'll perform our jump. Now, before we write our code for jump, let's check how the jump works. When the player presses the jump button, the very first thing we do is apply an upward force to the player. Once the jump force is applied, the player starts moving upward, but gravity is always pulling the player downward at the same time. So even while the player is moving upward, gravity slowly reduces the upward speed. Eventually, the player reaches the highest point of the jump. At this moment, the upward velocity becomes 0 for a split second. The player stops moving upward and then starts falling back down. Now gravity completely takes over, and the player starts accelerating downward. This creates the falling part of the jump. Back to our code. Here we'll say our velocity.y is equals to Mathf.Sqrt. And for value, we'll say our jump height, that is jump force multiplied with -2 multiplied with gravity force. This entire line calculates the exact upward velocity needed for the player to reach our desired jump height while still being affected by gravity naturally. Now let's call our handle jumping method inside update because jumping depends on player input and ground detection. Let's test our jump mechanics. Our player is walking smoothly. Now let's press the space key and test our jump. As you can see, our player jump is working perfectly. And if we press the space key again while our player is in the air, our code isn't letting the player to perform multiple jump. Now, our FPS controller has one more feature. Let's move to the next one for sprinting. Let's open up our player movement script. For sprinting system, we'll add a new float variable for sprint speed. Let's duplicate our walk speed variable and rename this as sprint speed, and initially set its value to 6. Next, we need a bool to store our sprint input. Private bool is sprinting. This variable will simply tell us, is the player sprinting right now or not? Inside our handle input method, we'll handle our input for sprinting as well. We'll say our isSprinting is equals to input dot get key, and key will be left shift. This will check if the player is pressing left shift, and if left shift is pressed, isSprinting becomes true. Otherwise, it becomes false. Let's test this input. Now, as you can see, when I am holding left shift, our sprinting is returning true, and when I release the button, it's returning false. Back to our code. Now, as you can see, we have 2 types of speed variables, one for walk and other for sprint. But here you can see our controller is moving with the walk speed. And if we press the left shift, it should move with sprint speed. We'll create a new float variable for current speed, and we'll store the value of our walk speed and sprint speed in this current speed variable, depending on whether our player is walking or sprinting. Let's add private float current speed. Now inside our handle movement method, we'll store walk speed and sprint speed in this current speed variable, depending on whether our player is walking or sprinting. Let's say our current speed will be equal to, if our player is sprinting, then current speed will be sprint speed, else current speed will be walk speed. We use ternary operator. It works same as our if-else conditions. Just like that, if is sprinting is true, then current speed is sprint speed, else current speed is walk speed. The above one line is working the same as our if else are doing. So it is better to minimize the code. Instead of writing code in 6 lines, do this in just 1 line. Let's erase these conditions and replace our walk speed with current speed inside controller.move, where we are moving our controller. Save script and test our sprint system. Let's move our player and hold left shift key. Great. Our sprint is working. And when I release left shift button, player is walking. Here you can notice when I hold or release left shift button, our player is instantly change the speed. I guess we should blend them for smooth and natural look. Let's open our player movement script. Now, instead of storing our walk and sprint speed in current speed variable, we'll create a new float for target speed. We smoothly blend current speed to target speed over time using Lerp. Here we'll say current speed is equal to Mathf.Lerp, and float A will be current speed, and float B will be our target speed, and time.delta time. And multiply it with 10 for smooth time. Let's test it again. Let's move our player. If I hold left shift now, you can see we are blending in between walk and sprint speed. Now it looks better, but still we have an issue here. Currently, our player can sprint in air as well, and it shouldn't do that. As you can see, while sprinting, if I press jump button, our player is sprinting, and if during jump, I hold the left shift, our player starts sprinting in midair. Let's quickly fix this issue with just one check. Right there where we are getting input for sprint, we'll add one more check and it's grounded, then our sprinting is true. Let's test it again. Let's move our player, and if I start sprinting and jump at the same time, our player stops sprinting. Now our player can only sprint when it's on ground. And now we have smooth sprint movement. Now let's add crouching. This is one of the most common mechanics in FPS games. Now let's start building our crouch system. And probably the most important thing in crouching is the height of our character controller, because crouching is really just changing the player's height. So when the player crouches, we reduce the controller height, and when the player stands back up, we restore the original height. Let's open our FPS controller script. Let's create some variables for our crouch system. Again, we need a speed variable for crouch speed. Duplicate sprint speed and rename this as crouch speed, and we'll set its value in start method. Here in start method, we'll say crouch speed is equals to half of our walk speed. Usually in FPS games, crouching movement is slower than normal walking. Next, we need a bool to store our input for crouching. Let's duplicate our isPrinting bool and rename this as isCrouching. Now let's detect crouch input inside our handle input method. We'll store our input for crouching. We'll say isCrouching is equals to input.getKey, and key will be left control. Next, we'll create a couple of variables to control the height of our character controller. Let's add a header for a crouch height setting to organize our inspector. Next, we'll add a new private float for crouch height, and we'll set its value in start. Let's duplicate this crouch height float for our original height. Now, inside our start method, we'll set values for original height and crouch height. Our original height will be equals to height of our character controller, and our crouch height will be equals to half of original height. Now let's create a dedicated method for crouching to keep our code modular and clean. We'll add a private void handle crouch. We'll use a switch statement based on this crouching. This checks whether the player is crouching or not. Let's add switch based on his crouching. And for true case, height of our controller will be equals to crouch height. And for the false case, we'll say our controller height will be equals to original height. That's how we'll control the height of our character controller. Now call this method in update as well. That was height controlling part. Now let's also reduce movement speed while crouching. Previously, we only handled sprinting and walking. Now we've extended the logic. First, it checks, is the player crouching? If yes, we use crouch speed. If not, then we check, is the player sprinting? If true, we use sprint speed, and if neither condition is true, we use normal walking speed. And we don't need this is grounded check for crouching as well. Save script and test the game. Let's hold left control button. Perfect. Our crouch system is working, and when I release left control button, our player is standing. But there's one problem. Right now, the player instantly changes height, and this feels very stiff and unnatural. Most modern FPS games use smooth crouching transitions. Let's fix this. Inside our handle crouch method, first we'll add the float for target height, and this will be equals to if is crouching crouch height else original height. Now we have target height. So instead of instantly snapping height, we smoothly blend toward the target height using Lerp. Here we'll say controller.height is equals to Mathf.Lerp, and it is between controller.height and target height. Over time, multiply with 10 as smooth speed. And now we can remove our switch statement completely, as we don't need it. Save script and test the game. Let perform crouching. As you can see, we have smooth transition while crouching. And now our FPS controller has smooth crouching, crouch movement speed, and proper height transitions. We can walk, sprint, jump, and crouch. And this is starting to become the foundation for a real FPS game. In the next episode, we'll start implementing our basic shooting mechanics. Follow Devbyte